Welcome to our NPTEL courses on the power quality improvement technique. Today we are going to discuss about the passive filter, that is the one of the element that we are using for a long time. We can use the capacitor, but capacitor has lot of problem, and for this reason we require to use a passive filter. So, passive filter can be tuned to the particular frequency. We will see that based on the classification of the filter, and ultimately thereafter we will see that how that is operated. It is nothing because it is a network theory. So, you have studied for a long time. Thereafter we shall see how to design the passive filter, that is one of the entities to be considered. There are limitations of the passive filter. Limitations of the passive filter is something that we require to understood very well. We have talked about those limitations in our introductory overview classes. So, we shall discuss in depth. Thereafter parallel resonance and all, this is one of the limitation of the these passive filters, and the detuning and other problem, and the problem associated with the parallel resonance also will be discussed in a subsequent time. So, traditionally a passive filters we shall abbreviate this one passive power filter. Please note that there is a signal level filtering, and that can be also the active filtering by the op amp. But once you are using the high power, then it has to be a passive power filters, and once you are using the active component of it, that will be shunt or the series active power filter, that will be also the power filter. So, it will be consisting of the higher power rating, not op amps, are used to reduce the harmonics, and the capacitance are generally employed used to reduce the harmonics. That is what I am saying, the capacitors are generally employed to improve the power factor of the AC loads, that we are doing for past 100 years till the AC supply has got the more predominance over that AC supply. But these passive filters, but if you use a capacitor, then with the advent of, or with the power electronics comes into the picture, you have adjustable speed drives and HVDC link, and these are generally generate a corresponding frequencies. That frequency we require to negate it. So, for this reason, and also there is a problem of the transients in case of the single capacitor, and if you tune it properly, then also that transient portion can be mitigated, and moreover it will respond to a particular frequency, and it will not, it will have a selectivity. And for this reason the passive filters is classified into the shunt, you can put them in parallel path, series, that a hybrid, you can put them shunt and series. Thereafter you can eliminate a single frequency, that is called a single tuned, and it can have a, let us say it will be eliminating only the fifth harmonic, then it is single tuned. You can have the frequencies will be eliminated by it, will be the double tuned, because it may be eliminating fifth and seventh. Thereafter sometime it required to be damped also, otherwise it will have a sustained oscillation. So, you require to damp it out. I shall take a special lectures after that, after shunt active power filter, the grid connectivity and the control associated with the grid connectivity, and it will be a general class and not restricted to the, and it will won't be restricted to the only the shunt active power filter, because with the advent of the microgrid now, shunt active power filter also the part of the microgrid sometime, and we can put the solar into the system, and thus it gives you integrated solution. So, we require to have a holistic approach on it, and there we can have a active damping as well as the passive damping, that we will discuss in detail in a subsequent class. Thereafter we can have a band pass, you allow a particular frequency to be passed, and you can have a high pass. So, you have a low as well as the low pass, and it may be more effective in high power rating system. For example, that is the nowadays we have a HVDC transmission line. You know that it has been seen that transmitting power through the HVDC or the extra high voltage AC line with the fax is a cheaper than if you have a thermal power sources than the coal. So, transmitting coal and land, whatever will be there, it will take more establishment cost than establishing a high voltage HVDC or extra high voltage AC lines. And for this reason, this is now getting a dominance into our distribution, into our transmission system. And here also you can see that in HVDC system, they are very much in use even nowadays due to the simplicity and low cost and the robust structure. So, we require to filter out, we want to have a DC from AC to DC, there we can still use a passive filter. The extensive used in hybrid configuration, that is the configurations of the AC and DC both, I have seen, I will show some example of the hybrid filter in the topological discussion of the shunt active power filter. So, configurations of the power active filter, where the major portion of the filtering taken care by the passive filter, but these statements now required to be validated, because with the time the cost of these IGBTs are decreasing, because it was high patent cost, and unfortunately for this reason the manufacturing, all those issues comes into the picture. Now, since 30 years been passed, more than 30 years, as IGBT came, so price has been decreasing every year, and for this reason but cost of the, once you are putting a passive filter, is the cost of the inductor and the capacitor. Inductor comes with the copper and iron. In general, this cost goes high, and this statement, even if it is validated in a particular rating, it may not be so for the other rating, and also gradually we may eliminate the passive filter once the cost of the switch goes low, and major portion of this filtering can be done by the active filtering, and a little bit of portion will be left to the passive portion. So, in the medium and the lower power rating, especially in the distribution systems, the passive filters are used because of their low cost and simplicity. So, it does not have a much voltage rating, so thus the and neither you have a big current rating, and due to that it will be very compact as well as very simple to design, and for its simplicity and other cheaper in cost, we prefer the passive filter. In distribution system requires the reactive powers quite low compared to the transmission system. So, also we may have a resistive network for the heating and all, and for this reason that small amount of the reactive power can be given by this entity. Hence, design of the passive filters become very challenging to the reduced RMS current of the supply, where dominance harmonics are due to the adjustable speed drive generally arises from the rectifications process. So, this is a big challenge, this portion. The design of the passive filters become very challenging to the reduced RMS current to supply, where dominance is of the harmonic current, and this happens once you are feeding the adjustable speed drive. The diode bridge rectifier at the front end of the component, and capacitor filtering the DC bus. That is the normal topology you have in the adjustable speed drive configuration. And what happened in this problem, why it is complicated? The above applications, the reactive power demand is quite low, but harmonic current are produced by them quite excessive. Fifth harmonic will be dominating one, and it has a huge amount of the fifth harmonic. Hence, low value of the power capacitor in passive filters, these filters become sensitive to the parallel resonance between the filter capacitor and the source impedance. And you know that it is anti-resonance, so less current flows. If parallel resonance frequency occurs, this results voltage distortions and harmonic current amplification. So, this is one of the problem in the assignment, we shall give this kind of problem. So, this is the one of the major drawback of the passive filters, and thus what happened, we have explained these issues in an overview. It just introduction of it. It leads to the blowing of the fuse or maloperation of the circuit breakers, and this is something is challenging. Thus, generally nowadays we use hybrid filter instead of the passive filters. Passive filter, now this is a classification of the passive filters. Passive filter can be classified based on the topology. Topology means how you can connect it, it can be single tune, double tune on all those issues. And the connections, it can be shunt and series. And the number of phases, it can be a 3 phase, it can be a single phase, it can be a star combination for the 3 phase, it can be a delta combination in 3 phase. There can be a T connection, there can be a pi connection, these are the topological aspects of the shunt active power. This is the topological aspect of the, passive filters. So, this is the overall classifications of the passive filters. So, passive filters are based on the shunt, series and hybrid. So, shunt you may have, you can connect in parallel to the load, then it is shunt, and you may have a generally most dominating features as shunt. For this is an passive resonance comes, band pass or tuned, you will pass, you have this kind of filters and thereafter you have a load, then this is a shunt or passive filter or this parallel filters, and there you have a band pass or tune, you may eliminate a particular harmonic, fifth harmonic. That it may have a high pass or damped, that means you will eliminate this kind of frequency response. This is a low pass and rather this will be high pass. So, you can have a high pass kind of entity, it will block everything after some frequency, that is low pass, and it will allow everything after some frequency, that will be the high pass. So, this is a 3 dB frequency. Same way we can have a series passive filters, that will be the band or block or the tuned. So, you will connect this inductor and the resistance capacitors and thereafter this capacitor, and this is a this can be connected in series. So, ultimately it can have a band reject. So, if it has a selectivity, it only pass a particular harmonics. So, it is band block or tuned. Now, it is high block or damped, that is also possible. It is generally we have to provide the damping in the series circuit, otherwise series resonance set in and high current will be flowing. So, this is we require to damp always damp these passive filters when it is in a series connection, and thus it is a loss. Generally you have to put a resistance in series, and we will see later by the control system also you can have active damping. So, high block or damped. Similarly, we can have the combinations of the series and shunt, and that is called the hybrid shunt and series, and in between you have a hybrid tuned damped filter. And for the band pass filter, it can be further classified into the single tuned. This is this entity. I just show the pictures after few slides. Single tuned, that is, it may eliminate only the fifth harmonic, it may eliminate seventh and fifth and seventh harmonic, then it will be double tuned, it may be actually tuned to fifth, 7, 11, triple tuned, and it may be fifth, 7, 11, 13, then this is multi tuned. Same way we can have a high pass or damped, that is a first order. We can, so it will have a 20 dB decay, we can second order we will have a 40 dB decay, third order we will have 60 dB decay, and we can have a C type also, that we will discuss in subsequent class. Same way this entity, you can see that band block will have a single tune as well as a multi tune, and for series also high block or damped, it can be 20 dB decay, that is first order, or 40 dB decay second order. These are the total combinations of the shunt active power of the passive filters topologies can be available, and the combinations can be available to you. The passive shunt filters are connected in parallel to the harmonic producing loads to provide low impedance path for the harmonic current. Ultimately, it will sink there, hence the harmonic current do not enter into the supply system or the distribution system. It flows through the passive circuits, preferably consisting of the lossless passive elements such as inductor, capacitor, to reduce the losses in the filter system. Losses in inductor cannot be neglected and are considered as an equivalent resistance connected series with the inductor. So, we have to add the resistance to accompany the losses associated with it. Now, this is, as I was telling, this entity is your single tuned. You have a capacitor, inductor, and though easier you can have an external resistance connected to it and to make it damped. Otherwise, the ECR and that is ELR can be lumped here as a resistance. So, and you have a particular the quality factor, you can design the value of R, based on that you can get the sharpness of the resonance. Similarly, you can have this one, it is same with this one, that may eliminate, let us say, fifth harmonic. Ultimately, you can have a combination of it, that is L and C parallel. These combinations is said to be the double tuned and can eliminate the dominating harmonic, let us say fifth and seventh harmonic. So, you have to design the fifth harmonic, the same value will come there, and for the seventh harmonic, that will be the parallel filters. So, then you have to design like this. Now, you can go to the another level. So, these combinations you can see that there is a this combination L1 and C, this comes here. Similarly, L2 and C2 comes here, and effectively there will be a L3 and C3 that has to be calculated. These calculations will be given in your assignments. So, you can make it to operate to eliminate the 3 harmonics. Similarly, if you have this one, this will eliminate the multiple frequencies, and this one is been preferred because of the series capacitor. It is cheaper in the size, but problem lies it has its voltage has to match. So, switching on and switching off has to be very proper, because this line subjected to the first charging to the capacitor is charging first. But in this combination, capacitor is charging through the inductor, that is something like the spring. So, for this reason the damping effect can be smoother here, and transient will be sustained more here if there is a state of if there is a little bit change of voltage and current, and otherwise this one will have a less sustained oscillation, and ultimately we do not want that sustained oscillation to be carry forward, and we require to damp all those passive and the active entity. So, the value of the capacitor is also known as the size of the filter. Value of the capacitor is also known as the size of the filter. Generally, you have to talk about the capacitors that will occupy a huge amount of space. So, ultimately this value will, because if it is a distribution system, voltage level is not very high, but the value of the capacitor will be quite bulky, will be high, and thus size will be bulky. It is decided by the reactive power requirement by the loads generally. It is already been placed. So, you know that what is the worst reactive power comes into the picture. Based on that, those compensation has been provided. The inductor value is decided by the tuned frequency, and you require to tune the fifth harmonic. You already know the value of the C. This comes into the picture from your reactive power demand, because you know that it is 0.6 kVR, say some value. So, from there this value of the C is fixed, and if you wish to eliminate the fifth harmonic, then value of the inductor has to be calculated from that. This type of tuned or the notch filter provides harmonic current and the voltage reduction. This is the one of the disadvantage of this kind of filter, though you can retrofit it, but it has the notch filter provide harmonic currents and the voltage reduction also. It also provides power factor correction because capacitive reactive power at fundamental frequency. You know, it is providing resonance to the fifth harmonic. So, you know, at resonance XL equal to XC. So, let us understand why. XL equal to XC at fifth, let us say at the fifth harmonic. So, 5 omega s into L, that is essentially 1 by 5 omega c. So, essentially what happen, so when you have at fundamental value of Xc is 1 by omega c. So, of course, you can see that Xc 1 is more than XL 1. Thus, what happened at fundamental frequency, since this capacity var is more, it will be correcting the power factor. The Q factor, that is called sharpness of resonance, another factor is Q, that is omega L by R or R omega C, whatever it may be. So, that because at the resonance omega L equal to omega C. The resistance of the inductor, generally you connect a small inductor with it. It is not that the parasitic inductor that comes into this with the copper wire, that is not enough. Decide the sharpness of the tuning, and it is responsible for limiting the harmonic current to flow in the passive filter. So, how much current it will flow, that you can, so you can have a flattened response, you can have a different value of the Q. So, sharpness of response, for sake of you have studied it. So, some values of the Q can be there. So, this can be there. So, how much current will flow at the resonance, this is your bandwidth. How much current will flow at the resonance, you can check it by putting the value of the resistance. Now, let us come to the double tuned filter, or the double tuned filters are combined in one circuit, and it is that is two tuned filters is combined in one circuit. It is called a double tuned or the double band pass filter. So, it will allow or eliminate, it may eliminate fifth and seventh. So, it can have this peak as well as this peak, or it can have fifth and seventh both. So, here fifth and there is a seventh. But if there is a sometime we manage with this if these frequencies are quite close, but we sometimes require to do it like this. For example, if you are eliminating, let us say fifth and 11th, so you have to do this way. It having minimum impedance at both the tune frequencies, since it is a we are talking about the shunt. So, that will, those current will sink through it. Another shunt passive filter is a high pass filters. It also absorbs all the higher order harmonic, generally put a very small capacitor, and this will take out all the switching harmonic and all those harmonics, and thus you will have a smooth waveform. It provides damping due to the presence of the resistors into the circuit. Generally, you have to have RC network, and RC network time constant will be the same close to your switching frequency. These filters have higher losses, but fortunately at higher frequencies not much higher current and power losses are present in the load. So, for this reason their rating, power rating is quite low. The passive filters have a problem of resonance with the source impedance. That is one of the greatest limitations of the passive filters, and for this reason gradually our shift is on active filter. Fixed compensation, poor power factor at a light load due to the excess leading operating power injection. This is the one of the major drawback of this passive filter, shunt passive filter. Thank you for your attention. I continue our discussions with the passive filter in our next class.